So when I was asked to learn about AI by my company, so I was into platform engineering team, I was thrown into the hard waters, okay. So I don't know where to start first of all, because AI, if you go and search, there are so many technologies, so many jargons. So I am trying to help help you how I learned it, okay. So that's what it is. So we are going to see the objective. So basically what mindset we have two kinds of people currently who are denial. You'll say that every year one hype cycle will come. So data science came, analytics came, blockchain came, and it disappeared. Okay, like that there is another wave is coming talking about AI. AI is not a new one. That is there for almost 70 years now, and people talk and walk away. That is one set of people. Other set of people, this is more prevalent now, in a panic. Oh my God, all software jobs will be gone, all support jobs will be gone, and we are all gone. Okay, so both may be somewhat true, but let us take a positive mindset. So this presentation is to bring a positive mindset. Okay, let AI be good or bad, doesn't matter. Let us deep dive and see what it can do and what it is all about. Okay, so the machines, when they are invented, they were earlier a steam engine or a diesel engine or a petrol engine. When they are invented, people were panicking. They can do more work than human can do, but doesn't mean that human became jobless. We were able to control those machines and improve our productivity. So why don't we try that with this AI mania that is happening? Okay, that's what we are trying to do it here. Okay, now let us simplify the AI jargons. Artificial intelligence, what is that? We will make machines to do work was automation. Okay, so the era of automation is all about we were making the machines do a particular task efficiently, more powerful, and repeatedly without any fatigue. That is what about automation. Now, if that machines can think and take some decisions by itself, that is about artificial intelligence. So this is there. Even the Turing invented the Turing machines to decode the Enigma codes. Okay, so from that onwards, there are so many people working on it and trying a lot of different algorithms to make them work. And this is and that is what artificial intelligence is all about. And this artificial intelligence, there are two types of artificial intelligence. Till now, we are excelling only in the narrow AI, and general AI is all about making humanoids, or the Optimus robo that Elon Musk is trying to produce is nothing but a general AI machine, which can take its own decision. It can also create its own skills. Like in Robo or in Endiran movie, Endiran creates another robo. That is actually a general artificial intelligence. So whenever it feels that I need a more skill, it can create a skill and adapt the skill. Okay, but we are not yet there. Okay, there are more studies happening there, but we are yet to go there. Now, in order to make the artificial intelligence works, we have to make the machine to learn. How we make the machine to learn? There are a lot of mathematical algorithms. So based on those algorithms, we have three types of machine learning. So one is supervised learning, where we teach it and it will learn, and then you will test it, and if it is okay, we will send. It's like A for apple, B for bat, what you learn in kindergarten school. And then next one is about the unsupervised, where jugad, like we will not go to school, we go to somewhere and learn by ourselves and became big Anachi stores or whatever stores that we make. That's a jugad way of learning. Okay, that is unsupervised learning. Reinforcement learning is combination of both. We learn by ourselves, but someone will come and give you feedback. This is right and wrong through my experience, and give them back, and they learn again. That is reinforcement learning. So these are the basic types of machine learnings we had. So if you want to play in this particular arena of machine learning, scikit-learn, TensorFlow, Keras, these are all the different libraries, open source libraries available. You can play in that area. But in these days, they were always predicting what is the next, basically classifying, prediction of next number, or forecasting. These are all the things that were achieved with these kind of machine learning. Then comes the deep learning. Deep learning, okay, can we learn how human learns? How human learns, we see certain things, and there are light pixels are entering into our eyes, and these eyes put some image in the retina. The retina is read by our brain in a particular layered approach, and then we will understand this is a human, this is my relative, this is my uncle, this is my girlfriend. This identification happened in a particular layered approach. The same layered approach was actually converted into a mathematical model called as neural network. In neural network, there are multiple layers of nodes. Basically, node is nothing but it contains a value, a numerical value between 0 and 1. 1 means is fully lit, and 0 means not lit, and in between 1.1, 1.2, 0.3, it is like any pixel value. Okay, based on that we were able to identify. So we'll move from one layer to another layer. So that's where the neural network came. Neural network, I mean, deep learning was possible only with the neural network. And then neural network paved the way for natural processing language. See, natural processing language, natural language processing, basically how we can understand a particular language and then we can react to it or understand it. Then comes the transformer. The transformer was the bigger leap in terms of generative AI. So till these days, we were only doing predictions, forecasting, those things only. But then we were started generating a content, generating a story, generating a poem, generating a statement. These things were possible only with the transformer. Transformers were first introduced to make translation possible. Okay, and transformers are all about attention it needed. There is a guy called J. Alamar. I will give you a link in this. He has written a very good white paper on transformers. It is all about attention. If you give a statement, you take each and every word in the statement and compare with other words to make which are the most important words in this. Okay, is, was and all not more important. And if you use a word called as it, okay, it means what? It's a human or it's a dog or it's a table. So like that, it will make attention to each and every words, and then it will add weightages. These are all called as parameters. When ChatGPT or anyone says we have tested with 8 billion parameters, these are all the parameters which are all nothing but knobs to tune the model to make sure that the results are better. Okay, so that's where the real transformation happened in the transformers. Okay, and transformers paved the way for the language models. Okay, does language models new? No. When IDEs were invented, we have intelligence or autocomplete. They were actually language models. If you go and develop a plugin for a Visual Studio Code, it will ask for a language model. They are not large language model. They are specific language model. Java is a language. Python is a language. A language is what? It has a syntax. It has a set of libraries. Based on the syntax, you can predict what should come next. What are the possible things can come next. And that's why the intelligence or autocomplete were already able to do it. Okay, that's what happened. But then the large language model is all about more unstructured language. Java, Python, or Java, we know the syntax. So we have a lexical parser to understand where what should be there or what should not be there. But when it comes to other languages, then they put a lot of language and train the system to learn by itself. Okay, without giving any grammar for it. So then language models, then comes the GPT. So we always talk about GPT is ChatGPT. No, ChatGPT is actually an implementation of GPT. It became like a Xerox. When first copier was introduced, Xerox introduced it, and everyone is now calling it as I'm going to take a Xerox. Same way happened to GPT also. GPT means a generative pre-trained transformer. That's the first time it started generating text. Okay, so we started generating text, and then it is pre-trained, which means we don't need to train it. We don't need to train a model. It's trained and model is already ready. And it is a transformer by itself. So it can do transformations. Okay, so that is a GPT. And the implementation of GPT is your Google Gemini or ChatGPT or the Llama. All those things are implementation of GPT technology. Now it's all right, it's all fine, but how we will interact with it? Can we talk in a normal English? Yes, you can talk, but if you want to efficiently communicate and get the best result, then comes the engineering called as prompt engineering. Prompt engineering is nothing but an English language in which we have 4 parts. First, the instruction, generate code, okay, and next context, code for what, and then you tell the inputs. So I want this code to be generated with a database as this and the file system as my local system. These are all the inputs. And the 4th part is what format you want. Okay, if you can give this in particular format, instead of just typing in the ChatGPT window with just typing whatever you feel, instead if you can structurally give the instruction, that is nothing but prompt engineering. Prompt engineering is very important to get the best results from any language models. Now, prompt engineering is maybe for the novice, but if you are a developer, I hope everyone is developer here, LangChain has given a library wrapper around it so that you can do better. You can ask better and you can integrate, because no business application will go to ChatGPT window or a Gemini window to type anything. I want it to be under the hood of my application and make my application better. Now, when our heart is very healthy, a physical heart, no AI heart, when we don't know that the heart exists. The moment I feel my heart is here pumping, it has disease. Same way, AI will be performing better when the application shows that the AI doesn't exist as such, but it does the job, it performs its task under the hood. So we have to develop application of such class. And one such application today people are talking about is AI agents. Now, AI agents are the applications that we as a developer, if you are playing an application layer, you should play there. And AI agents are like mini bots you develop for different tasks. Let us assume we develop an AI bots and Crew AI and Autogen Studio of Microsoft, and even Google has a model agent developer or agent modeler. These are the tools. Now, agents, what will happen is you develop, for example, you want a team, you can simulate a team using agent. There can be a manager, there can be a planner, there can be a developer, there can be a reviewer. And then when they have skills. See, each one has a different types of skills, and they can perform their task. So when an application is given or a particular task is given, a planner will plan the task. It will create n number of plans. Okay, and then it will be given to the optimizer. Optimizer will say, out of these plans, why this is missing, because optimizer is very, in our companies also, some people will be very good at finding faults. But if you ask them to develop something, they will not. But they are good at finding fault. But we need such people. Les Rajaram, he was my manager sometimes back, so I can ask him. But so these guys can keep feedback. Keep feedbacking. Now this planner will keep revising the plan again and again and make the best plan out of it. When the best plan is there, it can be given to the another bot, another agent called as manager, who will distribute the task to the, because he is good at managing. Some people are very good at managing. Okay, they know how to manage things. And then there are some guys who are only fit for writing code, and they can be given, this bot can only write code. This is again, we use the LLMs to do, but they are more focused on what they are supposed to do. They are clearly given instruction, you should do this, this or this. So these are all the development that is possible with AI agents. So as a developer, we should be focusing on AI agent development. That is very fundamental, and that is where we will move towards. But if you ask me, this is only the way, no, we don't know to predict the future. But as of today, a lot of people are talking about AI agents. Now, where is data science in all these things? That was most talked topic, I think 8 years or 7 years back, we worked on data science, and there are a lot of people roaming around called as data scientists also. I don't know where are they now. They are there. They are very much needed, because AI works on data. It is garbage in, garbage out. If your data is not curated, it is not cleansed, it is not engineered, what you get, if the data is not curated, the Taj Mahal will be in Africa. Okay, it is all based on the data, right? So data curation is there. So again, data science matured into a stage where it is actually in a nirvana state. It is existing, but nobody knows. It is omnipresent, like God. He exists everywhere, but nobody knows where he is. Okay, the same way, data science is the fundamental, still playing the role. There are so many companies playing in the data cleansing area. Okay, so data engineering, feature engineering, data transformation are very much important. And for that, there are so many tools called as Python, NumPy. There are remaining tools like MATLAB, Lib, Pandas. There are so many tools to libraries or open source. Okay, now I will quickly show what neural network is. Many people are very good in that, but I will just show. For example, if a particular system want to understand a handwritten digit, how it will understand? You say, let us take a 20 by 28 by 28 pixel image, and in that, so there are 781 pixels are there. In that pixel, I'm interested, if I have to find out, some pixels are illuminated, right? Light. So identifying, how it will identify, it's a 9 number. Okay, now, so these things are, the 784 is converted into a rows here. So they are called as input layer. The input layer, it identify which are all the pixels that are illuminated. Okay, the illumination is nothing but activation. Activation can be from 0 to 1, and 0 is not activated or not illuminated, and 1 is fully illuminated. First layer will identify the edges. Okay, it will identify this has reducing activation, and there is no activation. If those things are nearby, then it's an edge. So the first layer identify the edge. Second layer identify the patterns. So there can be many patterns. For simplicity, there is a round and there is a line. These are two patterns available. And then there is another layer will identify if the line and round is there. If it is round is there, only one round is there. it can be 8, it can be 9, it can be 6. Okay, and line and 9 and 0 and line is there, it can be 9 or 6. So like this, each layer will reduce it and finally find out it is 9. It's a very raw explanation, but lack of time, I'm just giving a very simple explanation of how neural networks works. Okay, there are 3 types of neural networks. The artificial neural network mostly work on tabular data, and images are mostly convoluted neural networks, and then it's a recurrent neural network is another topic which is used by the transformers and other teams. And transformer is a very interesting topic, guys. Please go, and there is a URL here, the Jai Alama's explanation of transformer. It is called as Attention It's All Needed, and it is the fundamental for generative AI. Without transformer, generative AI might have been not possible. Okay, and transformer is about you give a data. For example, there's a translation happening from a, I think it is Jesus, okay, maybe a Spanish word or something, and to an English, how the transformation happened or translation happened. That's where the transformer came into existence, and there they do a decoding and encoding. With every word, they compare the other words and find out the most valuable words. They give weightages to it. They do it in repeatedly again and again and again and again to identify what can be the possible next words that can do. Okay, and then choosing the right AI. So this is again, if I have data, for example, I don't have data, I don't have a programming skill, but I still want to use AI. Yes, that's possible. There are so many pre-trained models available in the web, or you can download it also and you can use it. Okay, they are called as pre-trained APIs. For example, Gemini is a pre-trained API, ChatGPT is a pre-trained API. They are available as an API format, CLI format, UI format. Okay, ChatGPT is available in the UI. Most of us go to the site, but ChatGPT is available as a CLI also. It will be available as a REST API also. And if you have data, but you don't want to do programming, then there are other models called as AutoMLs, which means if you give the data, they can do a training for you. Okay, and then they will do a proper model, and then they can deploy the model. In Google is very good at it. All the other frameworks also do that. Google Vertex AI is a suite. You can go there. It's very simple. You give your data, it will train it, and it will give you. Okay, and then you have to pay for it. And then the custom modeling is like, okay, no, I am a nerd. I don't trust on others. I will do myself. Okay, and that's what custom ML you can train yourself. Okay, if you want to learn from scratch, what are things to learn? First of all, data. So how you get data from actually how they are doing it? They are scrapping. They are, because through the search and all those things, there are scrapping tools like URL-lib, Scrappy, Beautiful Soap. These are all tools which can run through the network and collect a lot of information. But if you're a beginner, if you want data, then go to Kaggle.com. Kaggle.com is a collection of very beautiful data sets for all the domains you can get, and you can play with it. And then from mathematics, yes, mathematics is needed, very much needed if you are into algorithms. And then in mathematics, linear algebra, differential calculus, and statistics and probabilities are very important for you to learn. Programming language, Java and R are also good, but I prefer Python for one reason, because it has a lot of libraries available. Okay, packages available. And coming to IDE, you can use any IDE, but VS Code is now leading and with a lot of plugins available. And then machine learning modules, there are so many algorithms already available, and if you are good at mathematics, you can develop one algorithm or improve one of the algorithms. And for Tableau, for visualization, and Google has all these things together in a single platter. Okay, and typical AI process. So you ingest the data, analyze the data, and transform it. This is called as data management or label annotation. First you label the data or annotate the data, and then it is called about training. This is where you generate a model, and then you do an evaluate. This is explainable AI, because see, everyone do anything, but is it right or wrong? How much perfection it has? That is only come via explainable AI, and how this result, why this result came. So that is about explainable AI, and you deploy it in a particular scalable hardware, and then predict it, and it should be available as an API or SDK or CLI or as a UI. And we are talking about LLM. Everything ends with a model, right? What is actually a model? A model is a compiled program. You can take it as, which is executable. It is similar to that of Docker image, okay, but it is not Docker. I prefer it should have been a Docker image so that Docker engines can run, but it is not a Docker image. Similar to that, it needs a runtime. For example, Olama is actually a runtime tool using which you can run the LLM models. But what is an LLM model? For example, this is the prediction. Basically, LLM models will generate a formula for you. It is analogy, it's not exactly the same. So it will, for example, this is the linear regression. So basically, if you can draw this line, okay, and then that is actually can give you any prediction. Now, how you will draw this line? Because these are all the data points that we have, okay, but which line to draw? The problem is there can be n number of lines can be drawn, no? Which is the right line that we draw? The right line in this case is simple cases whose sum of these differences is the minimum. If you can draw that particular line, then that is the model, okay, and then we can use y is equal to mx plus b to predict the value. So this is a very simple, very fundamental model generation. A model is nothing but this particular formula that we have. Similarly, for LLM models also, it's a very complex algorithm. Finally, the model can predict which is the next word. Every word is actually maintained in a vector database. That's another story. Okay, now coming to a demo. Okay, LLMs are good. Do I have to go to the Google and write the LLM? Because some company says that it's very, you are asking Google and Google is generating the code, whether our company own the IP of the code or Google own the IP of the code. And when I ask a question to the Google, I am giving my IP out. Okay, because they know that what I am trying to develop. I don't want to do that. Is it possible? It is possible. You can have your LLM running in your laptop. I am running it in my laptop. So I have in my laptop, I have. So here Llama 3, the latest one which is released a couple of days back, is running here, and I am running it through using an Ollama, and here I can ask the questions and it will keep answering. Okay, which means every one of you, if you have a laptop, you can run, but Ollama has multiple versions. This is an 8 billion parameter version, which is the smallest one, and there can be 200 billion parameter one. I don't think my laptop can run that, but if you have better machines, you can run. Okay, which means you can have, many companies today are developing a co-pilot kind of an application, which is running in their own network, in the private cloud. They don't want their IP, because today there is no big laws governing the AI generated code. But in future, if Google says all the code generated by me is owned by me, and every company will close and call themselves of Google. Okay, so that is another thing. Here is this one, and then this is one of the thing, and then I am running out of time, so I will go fast. Okay, if I have a data, okay, but see, that is about running the LLM locally. What if, how can I do intelligence from the data that I have? For example, if I am a bank, I have so many documents, and I want those documents to be used for generating my result. That is called as embeddings. Okay, so this is the RAG. Basically, what happens is you will have all your private data, okay, and you do a chunk or split your data into smaller chunks, and then you do embedding. Okay, you do embedding. Embedding is actually converting your data into a vectorized format or a numerical format and store it in a vector database, so that the nearest meaningful words will be closer to each other in a vector space, a multidimensional vector, and then they will be stored in a vector database here. Okay, this is first part. When a query comes from your application or anywhere, the query also will be vectorized. The query is called as a context. It will be vectorized, and that vector also will come into this particular space. Now, these blue parts are your vector of the data, a vector representation of data. This orange one is actually the context. So based on that, it will collect using the nearest neighbor algorithm. It will collect the result here. These are all the next generated words. Actually, generate a word one by one, the next word, and then from based on that, the next word will be generated, and then it will go to LLM for getting more information about it, because your data will not have a lot of information. Your data will have a specific information, but if you want the relevant information from the large language model, it will get those information. It will not give you data, but will get more information from LLM and give the result. Okay, so this is called as augmented generation or retrieval augmented generation. So if you want to do a code, it's very simple. I will show you how you do. So basically you do pip install, okay, and then this is about initializing the libraries. It is about initializing the library LangChain. So LangChain is used for that interactions, the layer. And here I am doing a rate limit because I have purchase the license API key from Google if you don't want to do it. And then, yeah, I saw that. So here, this is very important. Here I am reading the alphabet, the Google's balance sheet. Okay, it's a public, so let us assume it's a private. I'm just reading it, and then I am doing a chunking of it. Okay, and here I am doing smaller chunks of it. Then I do embeddings. Okay, so yeah. So here I am using a vector database called as ChromaDB to do embedding. Okay, after embedding, then I can ask any queries. So when I am asking a query, what was the alphabet net income? This information is there in the particular document that I gave. It will give you answer. But if I ask who is the CEO of Google, Sundar Pichai, it is also there in the document answer. But if I ask a question saying that what is Sundar Pichai's relation with India, which was never, India as a word was never in the document, it will take Sundar Pichai, and then from LLM it will go and get more context about Sundar Pichai and his association with India, and it will give you answer. Okay, but if I ask something else like Sundar Pichai's personal life, it immediately says the responsible AI. This is called as responsible AI. I will not answer you because this is not appropriate to answer this question. This is very important, called as responsible AI. Okay, so this you can program it, and very simple for your personal data. For example, if you are developing an application for bank loan application processing, and in a particular task, there will be a lot of documents will be uploaded, and you can do a vectorization of that particular document and give a summary of it, and identify some poisonous class in it, identify the important information in it, identify the location of the property, whatever it is. Then if you identify the property and go to LLM and ask for, is there a litigation for this property, which may not be there in the document. Okay, this is how you apply it in your applications and build a very world-class application. And with that, I think my time is over. Thanks for listening to me.